take a look at this math message together. You have your angles A and B, right? And I say that angle B is larger than angle A. Do you agree with me? Why or why not? And think, what do we mean when we say one angle is bigger? So think about that for a moment. I say B is bigger. I'm like, well, obviously, right? These lines go on a lot longer, so angle B is a bigger angle, right? Wrong. If you disagreed with me, give yourself a pat on your back. You did the right thing. Don't trust your teacher. I was trying to trick you because the length of the rays actually has nothing to do with the size of the angle. If we put angle A on top of angle B, these measurements right here would match up perfectly. So these angles are actually the same size. Angle A equals angle B. And that's because when we measure an angle, we actually measure the amount or the distance from one ray to another. And do you know the units we measure angles with? We measure them in degrees. Good, so I actually did not accurately measure this before, and we'll talk more about angle measures later, but these might be something like 45 degrees maybe, and they are equal. And there's this little symbol we use for degrees. So those angles are the same even though the rays are different size. You already know quite a bit of angle vocabulary. We know a cute little angle, that's like this one, right here. That's less than 90 degrees, less than 90. Make sure you have that in your notes. Then we also know, do you remember what this angle is called? Obtuse angle. I like to say it in a deep voice like that because it's a big angle, more than 90 degrees. Measures more than 90 degrees, I should be saying. And lastly, when you have a square corner like this, that is a tip-off that this is a right angle, which means it equals exactly 90 degrees, also known as a square corner, also known as a quarter turn, which we're going to talk about more. So throughout these next few lessons, you'll be exploring angle measures. Today we're just going to talk about it in terms of rotation, and the vocabulary you use for rotation is full turn, three-quarter turn, half turn, or quarter turn. And we can also learn these terms counterclockwise and clockwise, depending on the direction the arrow is pointing. That tells you which way your angle is turning, and the way you remember that, obviously, is if you picture a clock, that's the way the second and minute and hour hands are all turning, right? So that's what we use to describe that direction of rotation. So let's go ahead first and figure out full turn, three-quarter turn, half turn, or quarter turn. So for this number one, the amount of rotation here, well, again, if we picture a full turn as all the way around 360 degrees, then now you can really easily see these equal pieces, right? And this is just a quarter of the whole, so we're going to call that one a quarter turn. And this is actually on page 178 in your math journal if you want to pause and get your math journal and follow along. And you know what, I should write out, because it says to use the words, so I should write out quarter turn because it said that in the directions. So always carefully RTD, but this time if you're listening carefully to directions in this video, I'm going to give you permission to write it in a fraction form. Save us a little time. Okay, this next one, the number two, what do you notice about that? That one's in fact a full turn. Okay, and then if we looked at number three, what's that one? How far is that? That is just a half of a turn. Okay, number 4. If you look, this is actually a 90-degree angle, a right angle, also known as a quarter turn. And this one I think is the trickiest one on the page because the angle is out here, right? So that's in fact what kind of turn? That's a 3/4 turn. If it were talking about this angle in here, that would just be a quarter. But since it labeled the arc outside, we know that's a 3/4 turn. And make sure you do number 6 and draw your own. Now let's look at this clockwise, counterclockwise vocabulary just to get the hang of it. In number 1, see how the arc, the arrow on the arc is pointing clockwise? So this would be a clockwise rotation. Whereas for number 2, the arrow on the arc is, oh wait, that one also, no, not a whereas. That one similarly is going just clockwise. But now, whereas number 3, if we look at the way this is turning, it's moving backwards like this because of the arrow. So that one would be counterclockwise. All right, CCW for counterclockwise. In the next ones, describe the direction of the rotation on your page as well. And that is all for angles today, but look forward to more information about how we specifically measure all sorts of different angles coming up soon.